Let's get started. Ranju talked about a lot of the infrastructure in terms of algorithms, tools like SageMaker and different technologies around supervised learning, reinforcement learning, and so on. I'm going to talk about applications we're developing at Amazon that use many of those tools, many of those algorithms, and so on for applications within the Amazon's e-commerce business, right? So I'm director of machine learning with the India business, but many of the applications we develop are also deployed globally. And of course, you saw some of the videos initially. We're using machine learning in many different innovative applications, right from robotics to Amazon Go, to drones in Prime Air, to image recognition, face recognition, search, and so on. So there's a broad set of innovative applications that we're applying machine learning to across our different business verticals, right, from AWS and retail. We're also, we're using machine learning to improve the experience for all our customers, our sellers, and also to improve the quality of our product catalog. We have a giant catalog with close to 200 million products right here in India and billions of products across the world. And we're also applying machine learning techniques to very many different types of data, right? At the bottom you can see it's spanning text, images, and speech. So what I'm going to do today is, dive deeper into some of the applications that are shown out here on this slide. Okay, so let's start off with address. Now, a customer's address is the single most important input that we use to deliver a package to a customer. Now, we are all interested in improving operational efficiency, and for this, we are using machine learning to both identify as well as fix poor quality addresses. So here you can see different examples of poor quality addresses. There may be addresses with wrong PIN codes. There are addresses with spelling errors. Here's an address with pretty much no spaces, right? I'm sure many of you in the audience are trying to figure out what exactly that address is. But our algorithms are able to, fix such sort of, addresses with errors and so on. And of course, sometimes we have these, let's see, can I go back? Oops. Yeah. Sometimes we have addresses that are incomplete here near Orion Mall, Malleswaram, Bangalore, and for such sort of addresses, we suggest phrases or words that the user can add to the address to make it more complete. So overall, we're using machine learning within the India business to improve the quality of addresses for customers. We've also got some fairly mundane applications. This is not something that would be the first thing that would come to your mind, but it's very important because a lot of our costs are in the packaging that we put our products in. So we're using machine learning here to determine the most cost-effective packaging to use for a product. And the key thing here is while we want to reduce the cost of packaging, we also want to make sure that we cause the least amount of damage to the product, right? You could put everything in very cheap packaging, but if it damages the product, that's not very useful. So here you can see different types of packaging in terms of increasing cost. So we choose the best packaging for a product that also concurrently will cause the minimum amount of damage to the product. We use machine learning to identify substitutes for a product. Now, when you're buying a product, typically you go and browse for many similar products, right? And in the end, you end up purchasing one of those many different products that you've been browsing within a session. So products that are frequently co-viewed but very rarely co-purchased are good candidates for substitutes. So we use algorithms that exploit a lot of the behavioral data in terms of the products that customers are browsing and what do they eventually end up purchasing. And so you may be thinking, how do we use this knowledge of substitutes? So one of the places where we use substitute products is to show customers low-priced substitutes. So if you're looking for a product, you may see some recommendations that are substitutes that have a very low price, or we also show customers substitutes when a product is out of stock, right? We can also show customers substitutes if a product is not locally available, but very close in the same region, a substitute is available, so they can get the product delivered much faster, right, than the product they were looking for, maybe that's not locally available. Ranju mentioned this. Amazon has been a pioneer in the area of product recommendations. We proposed collaborative filtering algorithms way back in the 1990s. Most of you have probably seen, our customers who bought this also bought widget on the Amazon product page. And this widget is powered, behind the scene by very highly scalable data mining algorithms that compute frequent co-purchases. And we also learn customer preferences from their, again, browse and purchase history. So we, again, leverage behavioral data a lot for product recommendations, and we recommend products to customers that match their preferences. So here you can see, your recently viewed items and featured recommendations. Again, on the seller side, we're using machine learning to forecast the future demand for each product. We carry a wide variety of products on Amazon. Everything is pretty much available. Now, it's very important to be able to forecast the demand very accurately, because if we forecast the demand for a product to be too high, then we are going to be stuck with excess inventory, and then you may have to liquidate the inventory. If it doesn't get sold, you have the cost of storing that inventory and so on. So you don't want to forecast the product demand to be too high. And these demands forecasts, by the way, are used by our ordering systems to order inventory. On the other hand, you don't want to forecast the product demand to be too low, because then the product will go out of stock, and this will lead to a poor customer experience. And again, as Ranju mentioned in the previous talk, Amazon is a customer-obsessed company. It's not just customer-focused. We are obsessed with customers, and having customers come to our website and then not see the product in stock would not be something that would be acceptable to us. So clearly, again, you don't want these forecasts to be too low, so that we don't order enough of the product. Now, in our catalog, as I mentioned earlier, we have hundreds of millions of products. Now, a key challenge for us is classifying these hundreds of millions of products into our product taxonomy. We also have a very large product taxonomy with over 50,000 leaf nodes. And customers browse through this product taxonomy to discover products. So accurate product classification is key to product discovery. So we absolutely have to be fairly accurate in the way we classify products. And for this product here, this red box here contains the root to leaf path in the product taxonomy for the product. So you can see this product is under jewelry, women, bangles and bracelets, and so on. So another thing I want to add, not only do we use a lot of the tools and software and the machine learning algorithms that are available in AWS and AWS SageMaker, but we also contribute a lot of our technology, as Ranju mentioned, work like things like product recommendations and so on are things that we've been doing for a long time, and a lot of the technologies like Amazon, AWS personalized and so on are based on those learnings that we've gained building recommendation systems for the past 20 years. Now, when multiple sellers, we run a marketplace in India, so there can be a lot of third-party sellers who are selling products on our marketplace. And when multiple sellers end up listing the same product, we have duplicates in our catalog. And again, this is not a great experience. You can see all these product listings here. They all correspond to the same real-world product. You can see that some of them have different images. The images don't all look identical. If you can see some of these titles also, they're different. But they all correspond to the same real-world product. And this makes it, it's a challenging problem because not all the images and titles are identical. And it's important to identify and eliminate such duplicates from our catalog for many of our applications. So for example, consider product search. You won't be very happy if you typed in a search keyword and we showed you these 5 product listings as the top 5 results, right? You don't want to see duplicates. You want to see a variety of different brands, perhaps. You may want to see related products and so on in the search results. Again, there's a lot of work in terms of developing algorithms to find near duplicates within the catalog using machine learning. And on the text side, we are working on extracting fine-grained ratings for attributes from reviews using, again, natural language understanding and sentiment analysis techniques. Some of the sentiment analysis techniques and algorithms that we're using are, again, from AWS. Now, this slide here is interesting. It's a screenshot of a website called DP Reviews, which focuses on cameras. And they provide fine-grained ratings for different camera attributes. As you can see here, you have things like image quality, video mode, ISO performance, and so on. So, there's a lot of different camera attributes, and the website will provide these fine-grained ratings, and they're all manually generated by experts. You can see the different experts up here. Now, we want to automatically generate these fine-grained attribute ratings by extracting all this information from our product reviews, because a lot of this information is embedded in the text within our product reviews. And we'd want to do this just not for cameras, but we want to do this for many, many different product categories, right? So that's one of the things that we're working on. And, again, using machine learning for that. Now, for the rest of my talk, I'm just going to dive deeper into 2 specific topics: question answering and catalog quality. Both of these are projects within my team. Now, the motivation here is that Amazon product pages contain a wealth of information. We have product descriptions that contain information about product specifications like battery life, camera megapixels, and so on. We have customer reviews that's shown here that capture user feedback and sentiment about different product features. We also have customer community QA data, that contains authoritative answers to customer questions. These are typically open-ended questions about people's experience with using a product or how a product compares with other products. Now, the average product page for the top 20 top-selling products across categories contains about 4,000 words. So clearly, finding information can be difficult. So to make it easy for users to find information that's embedded in these different product descriptions, customer reviews, and so on, we've implemented a question answering interface on our product pages. Users can type in a question in that red box there, and we'll generate an answer. Many different types of questions out there. So A majority of product questions are about product features. Here you can see the users asked a question, how heavy is it? It has a factoid answer. So many of these questions have factoid answers. The answer here is 8.6 ounces. It's extracted from the product description. Or many of the questions can have subjective answers that are available in reviews. So for example, here's a question, is it expensive? And here's the answer that's sort of extracted from customer review. For the price, this camera is good value for money for an amateur photographer. Now, one thing to see here is that the snippets that contain answers to the questions do not have high text similarity or high text overlap with the questions. The question here has the word heavy, but the matching snippet with the answer has the word weight. Similarly, the question here has the word expensive, and the matching snippet has the word value for money, which again doesn't overlap. So what this means is you need to do semantic matching between questions and snippets. And then there are product comparison questions that compare how two products, that compare two products with respect to different features. We have product compatibility questions that are about how well a pair of products work together. And there are a number of challenges. I'm not going to go through all of them, but in general, understanding the semantics of questions. A question like what is ISO refers to the definition of ISO, but if the customer asked a question, what is the ISO, just adding the word the changes the meaning of this question completely, and it's more about what is the ISO value of the camera. As I mentioned earlier, we need to perform semantic matching between questions and snippets. And that happens because you can refer to a product attribute like price in several different ways. Cheap, inexpensive, bang for the buck. There are all these different ways of referring to the same product attribute. We want to generate natural language answers. All the answers should have a very high degree of precision to maintain customer trust. And of course, you can get questions like, will this suitcase fit in the overhead of an airplane? Now, answering a question like that would require you to perhaps know the dimensions of the airplane. That won't be available on your page. And I'm not going to go into details, but we use deep learning and neural networks to learn these semantic embeddings for questions and snippets, so that similar and semantically related questions and snippets have embeddings that are close by, and that allows us to do semantic matching. And we have various loss functions that we use to optimize these networks. Again, I'm not going to go into all the equations and the details, but what we found is on different precision metrics, using our embedding and semantic approach provides much higher precision at rank 1 numbers, almost 96%, compared to using a baseline that's simple text matching based on cosine similarity. And here are some qualitative results for our question answering system. You can see for the first 4 questions, the answers we return are semantically matching. There may not be text matching. So for example, our question answering system figures out that the keyword basketball is semantically related to the word sports that we've returned in the snippet. Similarly, the question what is the price returns a snippet which has the word cost. Similarly, how big is it has a snippet which is item dimensions. Again, big and dimensions are semantically related, and our system is able to figure out those semantic associations. Okay. So with that, I'm just going to spend a couple of more minutes on catalog quality, some of the fairly interesting work. I mentioned again, we have close to 200 million products in our catalog. A lot of interesting information around title, image, descriptions. And customers place a lot of trust in the catalog. They make all their buying decisions based on what's in the catalog. So, poor quality catalog will hurt sales, will lead to more returns, and so on. So we pay a lot of attention to making sure that the information in the catalog is correct, consistent, and adheres to pre-specified guidelines. And now here are some examples of defects. You can see here with our product titles. And one thing in our catalog is it's all the information is uploaded by sellers because we are a marketplace. So a third-party seller can upload information, and that's one of the reasons why some of these product listings end up with defects, because we can't control everything that sellers upload. And some of these product listings may end up with defects. So for example, here you have a product title that is extremely long. There are some spam keywords that have been added to the titles by sellers, again, presumably to get more impressions. We also could have image defects. So for example, here this product image doesn't adhere to our guidelines. It doesn't have a white background. The image here is cropped. Here there are some examples of mismatches between the title and the image. The image here, the title says this is a t-shirt, but the image shows a bag. Here, the title says the color of the dress is blue, but the product image has a pink dress. Now, if you were a customer who placed an order for this product, you wouldn't know whether you're going to get a pink dress or a blue dress. So it's important to fix these problems. And here again, we are using deep learning to do text extraction, extract attributes like brand, color, size from product titles, and it's all powered by deep neural networks. We also do a bunch of things on images. For example, detect that this image here is defective, it's of poor quality. This image contains a color, a dress with red color, and this image here contains a t-shirt. So these are, again, we are using deep convolutional neural networks to do, for these different, to learn image representations for these different image classification tasks. And once we've extracted attributes like brand, color, category from titles, images, we can compare them and detect, product mismatch defects. So just to summarize my talk, AI and machine learning are at the core of our business. We've been working on AI and ML at Amazon for over 2 decades. Many of our technologies are now part of AWS services. We're also a big user internally within Amazon of the different AWS algorithms. Of course, deep learning is a very important technology, especially for learning semantic representations of data that we're using to power question answering, catalog quality, and product search, and a whole host of applications. So with that, thanks a lot.